Question 22. In the opposite figure, a motorcycle of mass 200 kilogram and its weight acts at the vertical line passing through the midpoint between the centers of the two wheels, and if the mass of the motorcyclist is 84 kilogram and its weight acts on the vertical line distant 1 meter behind the center of the front wheel, then the reaction of the ground on each of the two wheels equals. So the question about the reaction of the ground on the two wheels in kilogram weight. So the distance between A and B equals 140. According to the figure, the distance between A and B equals 140 centimeters. And the mass 200 kilogram passing through the midpoint of this line segment. Okay, so we have the distance between A and B equals 140 centimeters, and here in its midpoint we have 200 kilogram weight. It is the weight of the motorcycle, but the weight of the motorcyclist lies at the point distant 1 meter behind the wheel A, the axis of the wheel A here. Okay, so the distance between the motorcyclist and A equals 1 meter according to the given. So here we have 70 centimeters plus 30 centimeters equals 1 meters, as 1 meters equals 100 centimeters. So the distance between the weight and the wheel B equals 40 centimeters. Okay, the required here is to find R2 and R1. So in equilibrium, R1 plus R2 equals 84 plus 200. So R1 plus R2 equal 84 plus 200, which equal 284 kilogram weight. Okay, and this is equation 1. Now in equilibrium, the sum of moments of the forces about any point equals 0. So we will take the moment about the point A. MA equals 0. So you can say 200 multiply 70. It is the moment of the force 200 about the point A equals 200 multiply the perpendicular distance. What is the perpendicular distance? It is 70. And this weight acts in this direction, anti-clockwise, so it is positive. Also, with respect to the mass 84, the mass its weight also 84 kilogram weight. So we can say its moment about A equals 84 multiply 100 centimeters. What about the third force? Here the third force is R2. It is clockwise, so its moment equals negative R2 multiply the whole distance between B and A, which equal 140. So we write it is equal 0. And by solving this equation, what we get? All over 140 and the result equals 160 kilogram weight. Okay, since R1 plus R2 equals 284, so R1 equals 284 minus R2, and the R2 equals 160, so we write 160. So we have 284 minus 160. The result will be 124. So the solution will be at letter C. Letter C. 124 and 160. Next question, question number 23. If the two forces F1 equals AI plus BJ and F2 equals 13N and theta. Here is F2 in the polar form. Okay, 13 is the magnitude of the force F2, its magnitude, and the theta, it is the inclination angle to the positive direction of x-axis here. And this is the angle theta. These two forces F1 and F2 form a couple where sine theta equals 5/13. Then the required here is to find A plus B, the sum of A plus B. Okay, F1 equals AI plus BJ and F2 equals 13N and theta. Now we put F2 in the algebraic form. F2 equals 13 cosine theta plus 13 sine theta in the direction of J. But cosine theta, here we have sine theta equals 5/13. 5/13. Here is 5/13, and we know that sine is positive in the first quadrant, and also in the second quadrant it is positive. So here sine theta equals 5/13, and in this quadrant, in second quadrant, sine theta equals 5/13. But here the length of the adjacent equals 12. Here the length of the adjacent side, the third side, here it is 12 also, because it is the length. The length, it is always positive, but we will write it in negative sign, because it lies on the negative direction of x-axis. So from that we can deduce that F2 equals 12I plus 5J. Again, F2 equals 13 cosine theta. If you consider cosine theta equals 12/13, then 13 cosine theta equals 13 multiply 12/13, which equal 12. And the sine theta equals 5/13. 13 multiply 5/13 equals 5. So we write 5. Okay. But also cosine theta equals negative 12/13. So F2 equals 12I plus 5I, or F2 equals negative 12I plus 5J. As I said before, sine theta equals 5/13. It means the cosine theta equals positive or negative 12/13. So consider it once positive and once is negative. But the two forces F1 and F2 form a couple. So F1 equals negative F2. Substituting in the first form, we will get F1 negative F2, negative 12 minus 5, because you multiply negative by here negative F2. Okay, so we will get F1 equals negative 12I minus 5J. So A plus B equals negative 17. When F2 equals negative 12I plus 5J, okay, so F1 multiplying by negative equals positive 12 I minus 5j, and from that we write a plus b equals 7. 12 plus negative 5 equals 7. So the solution a plus b equals the negative 17 or 7, and this solution at letter B. Question 24. The center of gravity of the following system: M1 equals 1 at 2 and 3, and M2 equals 2 at negative 2 and 1, M3 equals 3 at the point 0 and 1 is. Here is a question about the center of gravity. How to find the center of gravity of the three mass 1 and 2 and 3. Okay, mass unit, kilogram, gram, it doesn't matter. Okay, so we form this table, a table of masses M1, M2, M3, and here we will write the coordinates x and y. The mass M1 of magnitude 1, M2 equals 2, M3 equals 3. The coordinate of the mass M1, x and y, 2 and 3 from the given. Also the coordinates of M2, negative 2 and 1, negative 2 and 1. What is the coordinate of M3? X coordinate equals 0, y coordinate equals 1. So we write 0 and 1. And we complete xg equals 1 multiply 2 plus 2 multiply negative 2 plus 3 multiply 0 over the sum of all masses 1 plus 2 plus 3, 1 plus 2 plus 3 equals negative 2 over 6, which equal negative 1 over 3. Yg, it is the y coordinate of the center of gravity, equals 1 multiply 3 plus 2 multiply 1 plus 3 multiply 1 here over the sum of all masses 1 plus 2 plus 3. So the result equals 8 over 6, which equal 4 over 3. And here is the answer at letter A. At letter A, negative 1 over 3 and 4 over 3. Question 25. A system consists of two laminas equal in thickness and density. Thickness and density. In form of two circles touching externally. Okay. If their equations are C1 x squared plus y squared minus 2x equals 8, and the equation of the second circle C2 x minus 10 all squared plus y squared equals k, then the center of gravity of the system is lying inside C1, inside C2, at the touching point outside the two circles. Okay, we have the two circles C1 and C2. I'll draw it. I'll draw a small two circles. One of them like this and the other like this. Okay. Here is the two circles touching externally. Okay. Here is the center of each. The center of the first here, and here is the center of the second. We have C1 of equation x squared plus y squared minus 2x equals 8. So its center 1 and 0. How we get it? Here is the general equation: x squared plus y squared plus 2lx plus 2ky plus c equals 0. Okay. How you deduce the center of the circle and the negative coefficient? Again, negative half coefficient of x and the negative half coefficient of y. So negative, the coefficient of x divide 2. Here, negative, the coefficient of x is negative 2. Divide 2, so it is equal 1. Here, what is the coefficient of y? It is 0. There is no y here. It means the coefficient of y equals 0. Negative 0 divided 2 equals 0. So M1, it is the center of C1 here. M1, its center here is 1 and 0. What is the center of the second circle? M2. It is here, it is in standard form. So x coordinate equals 10, x coordinate of the center, and y coordinate equals 0. What is the length of the radius of the first circle? R equals, according to the rule, L square plus K square minus C. Okay, L square, it is 1 square plus 0 square minus C. C equals negative 8. So we write minus negative 8 according to the rule of the radius. Calculated equals 3 length units. With respect to C2, we don't have C here, it is K, right? To calculate its radius. But we can calculate M1, M2. M1, M2, the length of M1, M2. M1, M2 equals square root of x2 minus x1 all square plus y2 minus y1 all square. Okay, so M1, M2, it is the rule, the distance of between 2 points. Okay, remember it. M1, M2 equals the square root of x2 minus x1 all square plus y2 minus y1 all square. Here we have 1 and 0, 10 and 0. So 1 minus 10 all square plus 0 minus 0 all square. The result equals 9. But the radius length of the first circle is 3, right? Here is 3. And the length of M1, M2 equals 9. So R2 equals 6. Now we know the radius length of the circle C1 and the radius length of the circle C2. Okay, but here they said the two laminas equal in thickness and density. Okay, so the ratio between their masses as the ratio or equal the ratio between the two areas, the area of C1 over area of C2. Area of C1 equals by R square by 3 square, and the area of C2 equals by R square, and the radius of the second circle is 6. So we write by 6 square, and the ratio equals by divided by equals 1, 3 square over 36. 9 over 36 equals 1 over 4. So let the mass of C1 is M and the mass of C2 equals 4M. Okay, so you notice that the mass of the second circle is greater than the mass of the first circle. So the center of gravity of the system lies in the greater circle, lies in C2. Question 26. If F is a force in the plane of parallelogram ABCD and M1 equals negative 18, here we have ABCD is a parallelogram, and MA equals negative 18 units of moment. It means the moment of the force F about A equals negative 18. And MB equals MD equals 32 units of moment. Then MC equals cam. MC equals cam. Here we have ABCD is a parallelogram. Then MA plus MC equals MB plus MD. Here is the rule. Okay, MA plus MC, MA plus MC equals MB plus MD. You have to memorize it. Okay, substitute MA equals negative 18 and the MC, it is unknown, equals MB plus MD. We have MB equals MD equals 32, and we write it and you can calculate it. You will get MC equals 82, and is the solution at letter B. Question 27. In the opposite figure, AB is a uniform rod. AB is a uniform rod of length 100 centimeters. The rod AB is uniform, so it is the weight acts on its midpoint. Let this point is E. So the distance between E and A equals the distance between E and B. Okay, AB equals 100. So AE equals 50 and BE also equals 50 because it is uniform rod. And the CD equals 50 from the figure. From the given figure, CD equals 50. Then AC. The question here about the length of AC. AC. The length of AC to make the reaction at C equals 1/4 the reaction at D. The required here is to find the length of AC in condition that the reaction at C equals 1/4 the reaction at D. So let R2 equals R. Okay, let R2 equals R. Then R1 equals 1/4 R. R2, it is the reaction at D. It is very important. Here, R2, it is the reaction at D. I'll consider it equals R. So the reaction at C equals 1/4 the reaction at D, which equal 1/4 R here. Okay, now this rod, this system is in equilibrium. So R1 plus R2 equals W. So we write R1 plus R2 equals W. W is the weight of the rod. But R1 equals 1/4 R and the R2 equals 1 R. So 1/4 R plus R equals W. It means 5/4 R equals W. Actually, there is no need for this step. Okay, W equals 5/4 R. Now, since the rod in equilibrium, the system in equilibrium, so the moment about any point equals 0. So MC equals 0. We'll take the moment about C. So the sum of moments of all forces about C equals 0. Now W multiply the length of EC. W multiply 50 minus EC. Okay, 50. EA equals 50. So EC equals 50 minus AC. Okay, it's clear. So we write W. Of course, it is positive. Why positive? Because it is anti-clockwise. So we write W multiply 50 minus AC equals R2 multiply 50. R2 multiply 50. Of course, the moment of R1 about C equals 0 because the line of action of the force R1 passing through the point C. So the moment of R1 about C equals 0. Okay. Now we substitute W equals 5 over 4R multiply 50 minus AC minus R2 which equal R here. R multiply 50 equals 0. Negative R multiply 50 equals 0. Why it is negative? Here because it is clockwise. So its moment, the moment of R2 is negative. Okay. Now we can divide both sides by R. Here by R. So 5 over R multiply 50 minus AC minus 50 equals 0. Now calculate AC. We can use calculator to save time. Here 5 over the result equals 10. So AC equals 10 and the solution at letter C. Question 28. In the opposite figure, triangle ABC is an isosceles triangle. M is the point of intersection of its medians. Okay, here M is the point of intersection of its medians. AD is a median, so CD equals DB. Okay. Okay. M is the intersection point of the medians. So the ratio between MD to MA equals 1 to 2. Okay. So if AD equals 3L, so AM equals 2L and the MD equals 1L. Okay. If AD, it's very important, AD equals 6, so AM equals 4 and the MD equals 2. Mass YXX has been attached to its vertices XXY. Then the relation between the values of Y and X. Again, then the relation between the values of Y and X, which makes the center of gravity of the system, lies at the midpoint of DM. Lies at the midpoint of DM. Here. They want the center of gravity lies at the midpoint of DM. I'll consider the new position here is M dash. M dash. Okay. So DM dash equals M dash. And DM equals half AM. Okay. I draw it here in this figure. Okay. But first, let us determine the center of gravity of the two masses X and X. Here is D is the midpoint of CB. So the center of gravity of the 2 points X and X lies at the point D. So we can cancel these two forces, two masses, and we write here 2x. 2x is the center of gravity of these two forces because D is the midpoint of CD, because AC equals AB, because ABC is a isosceles triangle. Okay. Now, what is the ratio between DM dash, M dash here, M dash here, M dash, it is the new center of gravity. Okay. Here we have 2x, here we have y. What is the ratio between DM dash and AM dash? It is 1 over 5. 1 over 5. Okay. Now consider the length of AD equals 12. The length of AD equals 12. Right? Okay. And the M It is the point of intersection of its medians. So the ratio between DM and the MA equals 1 to 2. So here it is 4, and this distance equals 8. Okay, so the ratio here it is 4 to 8, 1 to 2. But M dash, it is the midpoint of MD. So the length of DM dash equals the length of M dash M, each equal to, here is 2, here is 2, right? 2 units, 1, 2, 1, 2. So what is the ratio between DM dash and M dash A? It is 2 to 10, right? 2 over 10, which equal 1 over 5. Why I calculate this ratio? Because the ratio between y and 2x as the ratio between dm dash and m dash a. Okay, so y over 2x, here is the point of center of gravity. Again, y over 2x equals dm dash over m dash a equals 2 over 10 equals 1 over 5. Of course, you can prove it, the ratio between dm dash and the m dash a by another methods. Okay, you can, but I use this to make you understand quickly, I hope. Okay, so y over 2x, 1 over 5. Cross multiplication, 5 multiply y equals 5y, 1 multiply 2x equals 2x. So 2x equals 5y, and this relation in letter B. In the opposite figure, if the rod AB is in equilibrium, here is the rod AB in equilibrium, okay? And the AB equals 40, AB equals 40 centimeters. The tension in BC equals 60 gram weight. Here is the tension in the string BC. Here equals 60 gram weight. Then W, what is the value of W? Here is W. W lies in the midpoint of AB. Here we have 20 centimeter, 10 centimeter, 10 centimeter. So this distance equals 20 and this distance equals 10. It's from the given. Okay? Okay. Now, the system in equilibrium, so MA equals 0. When you take the moment about A, so the moment of x1 equals 0. The moment of y1 also equals 0. Of course, x1 and y1, the two components of the reaction of the hinge here. Here is a hinge at A, here at this point, or maybe it's ring. Okay, so that's why we will take the moment about A. The moment about A equals 0 because the rod in equilibrium. So 60 multiplied by 40 sin theta. Here, where is 60? The moment of the force 60 about A. Here, notice the direction of the moment of the force 60 about A. It is anti-clockwise, so it is positive. So 60 multiply this distance, perpendicular distance. Now to calculate the perpendicular distance, we must know the measure of this angle. What is the measure of this angle? It's 60. Why? 60 degrees. We have CB equals CA. It is given, right? We have the measure of this angle equal 30. and x1 و AC, x1 and AC are perpendicular. So the measure of this angle here, it is 90. We have 30, so this is also 30 degrees, 60 degrees. The angle CAB equals 60 degrees. But the triangle ABC is equilateral triangle. It is isosceles, so it will be equilateral. 60, 60, 60. Okay. Now AC equals BC. AC equals BC. Measure of angle CAB equals 60. So we can say that triangle ABC is an equilateral triangle. Now we know the measure of angle B, and we know AB. AB is the hypotenuse in this triangle here. So you can say that the length of the perpendicular distance from A to BC, from A to 60, equals 40 sine 60, 40 sine 60, minus W multiply 20 cosine 60. W multiply this distance here equals 20 cosine 60, cosine 30, minus the moment of the fourth, or the weight, 30 here. 30 multiply the length, this length, which equal 30 cosine 30 again. Okay. So the moment of 30 equals negative 30 multiply perpendicular distance. What is the length of perpendicular distance? It is the hypotenuse 30 cosine 30 here. After you calculate it, you will find W equals 75. Question 30. In the opposite figure, force of magnitude 6/10 acts parallel to the tangent to the curve y equals x power 3. Here is the curve. At the point 1 and 1, the point A here is 1 and 1, as shown in the figure. If the straight line L perpendicular to the tangent at 1 and 1, then the moment of F about B equals space. Here is a question about the moment of F about B. The moment of F about B equals F multiply the length of AB. What is the length of AB? What is the length? Now we know the magnitude of F, it's 6/10, but we don't know, it is not in the given, the length of AB. How we calculate it? Okay. First, we will find the equation of L. But before that, we will find the equation of the tangent, or we can find the slope of the tangent. The slope of the tangent to the curve here equals dy dx. L, it is the perpendicular to the tangent. Okay? So to know the slope of L, we must know the slope of the tangent to the curve y equals x power 3. So the slope of the tangent y dash equal the 3x squared. It is the first derivative. Okay? At the point A, 1 and 1, y dash equals 3 multiply 1 square. Substituting x equals 1. Substituting x equals 1. Okay? So we'll get 1 square. 3 multiply 1 square equals 3. So the slope of this ray, it is the tangent to the curve, equals 3. So what is the slope of the perpendicular? It is negative 1 over 3. Don't forget that. Remember that. M1 multiply M2 equals negative 1. The slope of the tangent multiply the slope of the perpendicular equals -1. And from that, you can deduce that the slope of the straight line L equals -1/3. Okay. So what is the equation of the straight line L? The equation of the any straight line is y minus y1 equals the slope multiply x minus x1. Okay. Y minus y1. Y1 and x1 and y1. It is a point lie on this straight line. What this point? This point is 1 and 1 here from the given. This point is 1 and 1 here, right? This point. So the equation of L is y minus 1 equals its slope -1/3 multiply x minus 1. When x equals 0, now I wanted to find the coordinates of the point B. At point B here, x coordinate equals 0. So what is the coordinate of y? When x equals 0, you can substitute here x equals 0 and we deduce y. Y minus 1 equals -1/3, 0 minus 1. So y equals 1/3 plus 1, which mean y equals 4/3. So the coordinates of the point B is 0 and 4/3. The coordinate of the point 0 and 4/3. Now we know the coordinates of the point B here and the coordinates of A. So what is the distance between A and B? What is the length of AB? To calculate AB, we use the rule of the distance between 2 points. AB equals square root x2 minus x1 all square plus y2 minus y1 all square. Here we have B and A. Okay. Calculate it, you will get root 10/3. So MB equals F multiply AB. F equals 6 root 10 and AB equals root 10/3. Calculate it, it will be 20 and the answer at letter B.